Alright, today we're going to talk about the 5 postulates. Postulates, what are they? They're also known as axioms, and they're statements that are accepted as true without proof. In geometry, we're going to do a lot of proofs, but these are 5 things that we can't prove. The 5 postulates are the foundation of Euclidean geometry. So anytime I say the 5 postulates, these are the 5 that I'm talking about. And there will be other postulates that we see in geometry, but they will have specific names. These 5 all go together, and that's because they're all about points, lines, and planes. And they're also, again, like I said, the foundation of geometry. You don't need to memorize the order of the 5 postulates, but you do need to really work with them a lot, because you need to make sure that if I start a postulate that you could finish it, and also you could paraphrase any postulate as needed. So if you're in a situation where you're thinking there's a postulate that has something to do with this, you should be able to put it in your own words and tell me about it. So at first you may find that you do need to try to kind of memorize them, but then eventually get to the point where you can just put it in your own words. So let's start off with the first postulate, and there's just one lonely point here. Now I want you to imagine a line going through that one point. Now, do you think everyone who watches this video is imagining the same line? You could imagine a line that goes straight up and down, that we call a vertical line, or you could imagine a line going straight across the screen in a horizontal fashion. You could imagine a diagonal line. So there are many lines that go through this point. Here's the second point. Now I want you to imagine one line that goes through both of these points. Do you think that everybody is pretty much imagining the same line? Is it going straight up and down? Or is it horizontal? Or is it diagonal? So there's only one possibility for a line when we talk about 2 points. That's the first postulate, and you'll want to write this down too in your notes. Through any 2 points, there is exactly one line. 2 points is the perfect amount of points to figure out what line you want. Okay, now here's 3 points. These are non-collinear. That means you cannot make one line that goes through all 3 of these points. And we can, though, have a plane that contains all 3 of these points. All 3 of these points lie on that plane. And that is the second postulate. Through any 3 non-collinear points, there is exactly one plane containing them. Alright, let's move on to the next postulate. Here I have a plane and 2 points that are contained in the plane. And again, if you recall, you can have a line that is formed by those 2 points. And now how do you think the line compares to the plane? Do you think that that line will ever leave the plane? Remember that the plane goes on in all directions forever as well. So even though that line, those arrows will go off to the left and right, the plane also continues in that direction. So let me rephrase the question a little bit here. Do you think that that line will ever rise above the plane or sink below the plane? Will that line ever leave that plane? And you should be thinking, no, they're going to stay together the whole time because those 2 points are on the plane. That is the postulate. If 2 points lie in a plane, then the line containing those points lies in the plane. So that was the third one. Let's move on to the fifth one. Here are two lines that are intersecting. How would you describe the intersection? What shape is at that intersection? Oh, here we go, bouncing ball. That point there. There's a single point of intersection. Because remember, these lines have no width, no breadth. So when they intersect and cross, they're only intersecting at a single point. And will they ever come back again to intersect at another point? No, those four arrows you see, those four rays that make this, they're all going off in different directions. So this is the fourth postulate. If two lines intersect, then they intersect in exactly one point. Alright, our last postulate, also about intersection. This time, instead of two lines that are intersecting, what two geometric figures are intersecting here? Those are two planes, like two pieces of paper going through each other. So right at that point where they meet, right at that, well, line where they meet, there's a line. That describes the intersection of two planes. And that's what the fifth and final postulate says. If two planes intersect, then they intersect in exactly one plane. Let's do some follow-up questions. Number 1. What is the intersection of two lines? State the postulate that supports your answer. So imagine two lines and they cross each other and they touch. At that intersection, what geometric figure do you have? Is it a point, a line, or a plane? The intersection is one point. So your answer is point. And the postulate to support the answer, it's the fourth postulate. If two lines intersect, then they intersect in exactly one point. Number 2. Similarly, what is the intersection of two planes? Imagine two planes colliding and they go right through each other. What geometric figure do you have at that intersection? Is it a point, a line, or a plane? And you should say line. That is the fifth postulate that says if two planes intersect, then they intersect in exactly one line. Number 3. What is the intersection of a line and a plane if the line is not in the plane or does not lie in the plane? There's a typo there. So we haven't talked about this one yet in the postulates. So it's a different question. We haven't seen this in the postulates. Imagine a plane. You could use your desk as a plane, and then imagine a line going through the desk. You could use your pencil and have it pointing down at your desk, and imagine it goes through the desk. At that place where they meet, what is the intersection? And you should be thinking point. Right where that pencil touches the desk, all you're going to get is a point.